this little video about how to curve the grades. I'm going to try to use an example and show you how the process works. So let's say I've just finished an exam and I have some exam grade scores. Let's say we've had 50 questions and the students can collect 76 points for the exam, but we need to translate that into a grading that we can use for the grades with the different policies we have about our grading and our grading scheme. We have one score per student, and you can see here on the side that the average scores that we have is 55 out of 76, and that's what the average student is scoring. So we can't just use 55 in order to grade them. So what do? We have to transform them. So what we normally do is to take the raw scores, and then we just do a percentage of the maximum, which is in this case 76, right? So once we do that, then we have something that we can compare. The problem is when that score does not hit where we want to be, then we actually need to do more than just take the percentage of the max in order to get the grade that we need for the class. So what do? Well, there are actually two ways of grading after a curve. So there's not just one way to do it. You have to decide which way is right depending on your situation. So normally our school, our university will have a policy in terms of what grading scale we're using. So we know kind of what range we need to be in, and normally we also have a recommended either a target grade, an average grade, or a grade range in which the grade needs to be for the class. And that's what gives us certain issues in terms of how we set up our grading. Also, if the exam we have is too difficult, like mine has been, that's when we don't get a lot of students that score towards the maximum, and that's also a condition from which you need to grade curve the grades. So the curving methods, basically you have two things to choose from. You have either the lift model, which is where you look at the raw grades, you transform that into percentage of the max, and then you lift up everyone so the highest scoring student will get 100%, and everyone is then scored from there on down. So that's called the lift methods. So the lift transform the actual scores to grades relative to the best scoring students. And the same score is then added to each of the students' scores, so they lifted up with the same amount of points. So it becomes fair in that sense. So the internal distribution between the students is kept. We're just moving up the students, so the best one will get 100 points or 100%. The other method is what's called the distribution method. So let's say we have a number of grades, then we decide how many students should be in each bracket or in each bucket. So that's called the distribution method. So if you see a bell curve and you look at the grading and it should be graded after a bell curve, that means that you have to have a certain amount of people in each of these bins with the different grade levels. So that's called the distribution model. And in order to use the distribution model, the professor needs to set a fixed score for each of the grade levels. So what percentage should you get in order to be in this kind of, let's say, B+ or A-. So what is the threshold? What is the grading scheme for that specific exam or that specific test? Then students are put into the groups, and depending on that threshold score, then that'll determine where the student ends up. So that's the two methods. We have the lift method and the distribution method, and you can see here on the screen how they stack up against each other. So distribution method will typically follow a bell curve, whereas the lift method, if you look at the grade distribution, will follow the distribution that we have in the raw scores. Now, which one is better? Well, that is up for discussion. It's also up in terms of what policy the school has. I do think if there is no set way to do it, I do think that I favor the lift method because it keeps the internal distribution amongst the students and doesn't mess with the distribution. But this is depending on the policy of the school or of the situation which you find yourself in. So there's not a right answer here. It's just a matter of making sure you pick the right one. If the school has a policy, you got to follow that. If the choice is free, I will definitely recommend that you consider the lift method. That's because that typically seems a little more fair to the students than the distribution method. All right, so let's take a look at the two methods. So first I'm going to go through the lift method. I'll show you, walk you through the process, and after that I'll show you how to do it with the distribution method. Now, before we talk about the details step by step with the lift method, let me just say that there are two versions of the lift method. There's a standard lift, and if that doesn't hit where we need to be, then we have to do what's called a calibrated lift. So I'm going to go through those steps and you'll see what is what. Normally we start with a standard, and if that's good enough, that's where we go. But if it's not good enough and doesn't hit the policy, then we have to calibrate the grades in order to have the grades curved. So let's take a look. So let's see, we have a set of test scores, and you can see that on the screen from 47 to 68. That's the data set you just saw. So either we can choose the lift method, and once I'm done with the example, you can see the results here, that we can lift it up. So the lowest will be starting at 80, and the highest score will be 100. And then you can see that distribution is more or less kept like it was originally. Or we could choose the distribution method, in which you can then see how the students are split then in the different buckets. In this case, because we want to hit an average grade of B+, you see that's where we have the highest level of scores by the distribution model. But we're going to go with the lift method first, and let's take a look at that. So here is again the grades that you have for the students. You can see in the yellow area the raw exam scores. 76 is the max score, and then the actual scores are underneath. You can see that we have 54 questions, and the first thing I do is analyze the actual raw score. So you can see here at the bottom, we calculate the average, also the mean and the median and the minimum and the maximum, and then we put in the target that we're after, and that depends on the school. So one of the schools I'm working for right now, we know we had a demand saying that you should hit around a B+ after hours grading scheme. That means that we have to hit between 86.5 and 90% for the students, and that's why I've set the target for this class as at 88. That's what I want to hit with this class. Now you can also see that we've calculated the percentage of the max. So you can see here on the right side that we've taken 48 and divided that by 76 in order to get the percentage of max score for all the different students. Now at the bottom here, you can see when you do that for all the different students, the average score will be 73, and that's quite far away from the 88 where we need to be. So therefore, the percentage of max cannot be used for grading if we need to hit the target of 88%. We are 15, as you can see, 15% or 15% points under where we need to be. So that's why the percentage of max cannot be used for this class. Now, the normal steps would be check the max score first. Once you have analyzed, you raw score average and the range and the percent of a max, if that doesn't hit it, then we have to go to the second level, and that is where we have to calibrate the grades. So let me show you how that is done. So step one, we do this calculation, and in case you don't know how I put up these formula, I just want to show you what you can put into your Excel sheet. So you can see here that the percent of a max scores are pretty simple. So we use a formula where we call out the single cell. In this case, we have C4, which is 67 points. We divide that by the max, so that's C3. We put a $ on C3 because once we copy that to the other rows, that one stays the same. So that's the simple formula for calculating the percentage of max. You can here you can also see the formulas that we put into Excel in order to calculate the average, median, mean, and max. So that's pretty simple in order to calculate. All right, as we know, it's not good enough because we hit 73 points, or 73% as the average, which means that we then have to lift up the scores, and that's why we call it the lift model. It's really simple. You can see that the difference we have from 73 to 88, that is 15 percent points. So we need to go up there in order to hit the target. However, the standard lift method goes up from the top scoring, from the maximum score. So in this case, we have 88% as the maximum. So in order to move up all the students towards the maximum, we then look at the lift between the maximum and the 100%. So we have from 88 up to 100. So the lift we need is then 11.84%. So this 11.84% is then added to all the different percentage scores that you have here in the column. And when you add those ones up, you can then see that the grade percentage score is lifted up by those almost 12%. So we dunk them into the column. We again calculate, the median, the mean, the minimum, and maximum to see if this brings us where we need to be. And if it does, then we're done. In this case, it does not. You can see it brought us up to an average of almost 85%, but that's still 3 points and 21 from where we need to be. So in this case, we can't really use it. So what I typically do, I check out not just the percentage score, but also the grade points and the grade to see what happens here, if it's going to be acceptable. And in this case, it's not, because you can see the grade point average is around 3. And we wanted to hit 3.3, so we are a whole grade step away from where we need to be. So this is a no-go in this situation if we want to adhere to the policies that we have. So in this situation, then we have to go to what's called the calibrated lift. So we have to take a look at how we lifted that little extra in order to hit the grades that we need. So how do we do that? Well, in order to do so, we again have to lift it a little bit more. And in this case, we're looking at the average. So you look at the average we have, which is about 3 percentage points too low. So what we do now is then we add those 3.21% to everyone. So we lift it a little bit more. And then we check where we are in terms of the grading. So, and in this case, you can see here on the side, we lifted up with 15%. And when we do that, the average is where we need it to be. Now, we have to check the minimum and maximum because that's the grade range. And in this case, you can see we have students that have more than 100 and we can't have that, which means that we have to mess a little bit with the numbers in order to hit a maximum that is acceptable. So basically, let's say you can see if you look at me here, the curve goes a little up and down. We have to move that together a little bit so we can get the ones that are over 100 down under 100, and then we normally push the distribution from the other end. So we push it a little bit from both ends in order for it to be under 100 without moving the average, right? So we pushing together. We're still keeping the major elements of the internal distribution of the data set, which is pushing a little bit from the sides. Then how do we actually do that? Well, for that, you have to look at the grades that you have in a ranked order. So the next step is then to rank order all the different grade points, grade percentage points. So we have them with the top scoring at the top and the low scoring at the bottom. And you can see I've done it here on the screen next to me. So the top scoring students has 103.2 and 101.9 and so forth. So what I do in order to push it down is actually, we can run some formulas as well, but normally I do this manually. So I said, all right, let's give the top scoring 100. And then the question is, what do we get number 2? So I'm looking at the distance from 103.2, number 1 student, to 101.9, and say, all right, so how far is that distance? In this case, we have about 1 percentage point distance. So I say, all right, on the other side, I'm going to just take a half off because I've got to push it down. And when I push it down, I can't use 1 and bring everything down with, because then we're going to be where we started up, right? So we're going to lower the average. So I'm going to push it down a little bit, but only half the distance. So the top students get 100, and the next student will then get half of the original distance, which is now 99.5. Then I look at number 3. Our original score has 100.6, and number 2 had 101.9. That's also 1 and a little more score. So I say, all right, I'll bring that student down by another 0.5%. So we keep the internal distance, the relative distance the same. And for student 3, 4, and 5, they've got the same score, which means that they have to get the same points, so they get 99. Then we go to student number 6. So we have a jump from 100.6 of the original score down to 96.6. So that's 4. That's 4. So let's do half of that again, and that's 2. So I subtract 2 on the other side, so student number 6 get 97. Now 97 and 96.6, if you round that, that's the same. So now we're actually down to where we need to be. So that's what I do with the top score. So now I pushed everyone down. Now in order not to lower the average, we have to push the bottom up a little bit. So here on the screen, you can then see how I've done that. So I take the last one, which scores 76.9%, and I lift that student up. In this case, I lift it up with just a single score to 78, and then I do the same process as I did with the top score, just in reverse order. So I push them up with the half the distance until I hit the same number on the left side. So with the target score lift and then the compressed and the calibrated score points. So you can see, in the gray area that, I have 78, it goes up to 79, and then with student, I think it's student number 8 or 9, you have the original score being 79.5, and then we have 80 on the other side, and now they're calibrated, now they're on the same level, and then we just round up the rest of them. So that's how we push it from the bottom. Now, what is then the results of this? And of course you can follow that if you put up the formulas for the average and minimum and maximum for all the different cells that you have. And in this case, you can now see that our average is exactly where it needs to be. So 88.01. So that's exactly where we need it to be. You can see the max score is 100, which is perfect. And then you can see, okay, the minimum score has gone up by 1 point. So, but now everything is green. Everything is where we need it to be. So we have kept the internal distribution distance more or less between all students. We are hitting the maximum we need. So now we're actually done. So this is how you actually do great lifting and the calibration if the lifted score is not enough in order to hit where you need to be. The second model is the distribution model. And let's take a look at that, how that one works. So we start with the same data. You can see that here on the side. And we still have our 50 student, and we still have the max score of 76. So the first thing we need to do here is to decide the scope and the share of grades for each grade group, right? So basically it's, how many grade groups do we want? So does it go from A to where? And then how many students in percentages of the total do we need in each of these brackets? And there are a number of different choices to choose from. I'll show you some of them in a minute. But basically that's what you need to decide first. So let's take a look at the different types of models you can have. I've shown 3 here. So we could choose to have a true bell curve with a standard deviation like there is in a true bell curve. If we use that, and let's say we want to spread the grades out from A to, let's see here, what do we have here? B minus. We have C minus as the minimum. Then the bell curve with a standard deviation would look like this, right? And there you can see the percentages of each of the brackets. So that would be the standard bell curve with the standard deviation spread out in that range we've chosen. Now, in this one, we then have 8 different grade brackets, and we have a target percentage for each. And then we will use that in order to divide the students up into each of the groups. We could also use a simple one, which is a 5-bracket grading scheme. Normally, this one will hit B plus if we want to use it from A, I minus, B plus, B, and B minus. So you can see here that the average grade will hit B plus. In this case, could be hitting 88% points. You could also go with a 6-bracket. So you divide that up. So that's another option. But you have to choose one. How many grade steps are you going to have, and what percentage do you want in each? And that's a necessary thing before you can start curving the grades. So let's say you decided that. I'm going to go with from A to C minus. So I'm going to use the 8-step methods, and I put you can see the list here, the grades, the decide share in each. And then the next thing I do is then from the rank order of my students, I then input a cumulative percentage column. So I can calculate how many students is at this raw exam score or higher, right? So you need to make that cumulative percentage graph. So you can use that. And then you basically look at the desired share. You do, again, the cumulative share of the desired share. And then when you have these ones, then you look at, let's take a look at B plus, for instance. So the desired communication share would be that we would need about 16% of students that gets a B plus or higher. Now, if you then use the cumulative percentage column where the raw scores are next to the yellow column, you can see that the 16%, we hit that when we have 61 points. And that's why on the right side, in the score index, I've inputted 61. I've done that for all the different grade brackets. So we're using the cumulative percentage to identify what score index do we need to hit to get a certain grade for a student. So we input everyone, all of these ones, according to the desired share. And you can then see that the score index is that you need to get 67 points to get an A, 66 points to get an A minus, 61 to get a B plus, and so forth. And you have to get a 47 to get a B plus, and that's the lowest score. So that's why we don't have anything underneath that. So in this case, that's how we've done the distribution. What is interesting here is that we decided to go with the 8-bracket one, but because of the way the scores are distributed, we actually do not have anyone with a C minus and a C for this class because of the distribution brackets we have. So that's an interesting situation, right? So if you're using a distribution form, this is the scoring index you need to use in order to figure out what grade each student has. So that's how we do it. Let me show you a couple of the formulas here. So in order to do the cumulative percentage, you can again see that this formula resembles what I've showed you before. You basically take the score on the left side, and you then add the score for the next percentage, and then you just do a cumulative addition of that as you go down the different rows, as you go down the cumulative percentages. So that is pretty simple. And that's it. So the next step is then just what a student needs to get a certain points. You have ranked ordered the different exam scores, and then it's basically to input the points or the grade points for each student, or the grade if you want, or both. So you know that the top score that has 67, you can see that in the yellow raw exam score, gets 67 and it gets an A. The next one has 66, that will be an A minus. The next one has 65, that is a B plus, and so forth. So you just see that you used your scoring index to insert the grade depending on the raw score. So that's what you do. Normally, once you're done with that, you can do the average, median, mean, maximum calculation to see where you are. So in this case, you can see that the average is 3.39, so it's a B plus, and it's very close to the target of 3.3 that we had as a target for the class. So if we're happy with the distribution form, we're done. Now, the discussion about curving after this type of distribution is normally centered around the scoring index, right? So if you look at your original scoring index, if you get a 66, you get an A. If you get one little point less, you get a minus, and then the distance now to the next bracket is 5, and the distance to the next bracket is 6, and then it's 6 again, and then it's 2. So in terms of your point score, they don't have like what's called a natural distance between each other to go up to the next grade level, right? So is it unfair that one that scores 66 and 67 and then 65 are separated this much versus ones that might score 49, 50, and 51? And that's where the discussion comes in, right? But again, if you decided on the distribution model, you have to split them up and you have to get these index scores so you know who goes where. So that's basically how you do it with the distribution model. So in conclusion, 2 models for grading, for curving a grade. You have the lift model, so you have the standard lift, and then you have the calibrated lift, depending on whether the standard lift is good enough. The other method is a distribution method where you choose how many students and what grading buckets do you need, and then you use that to make your schedule for your specific type of exam. Lift method has 5 steps. You identify the actual scores, scoring policy of your school, and the grading schedule. That is necessary input, of course. Then you determine if the raw scores, so the percentage of max, can be used. And if they can't be used because the average is off where you need it to be, then you need to use the standard lift score, where you move everyone up. So the best scoring student now get 100%, and then everyone is graded relative to that. If that is not enough, then you have to go to the calibrated lift score, where you move up the average where it needs to be, and then you push the top and the bottom a little bit to get under 100, but still keeping the same average grade. So that's the lift method. For the distribution method, it's a 4-step process. First of all, you decide the scope and the share. So the scope means how wide a grade range do you want, how many different buckets do you need, and then how many do you need in each of the buckets, so the percentages in each bucket. That's where you start. And after that, you then assign and identify what specific points do you need to get in order to get into each of these brackets. And then you assign each student to each grading bracket that you've set up. And then you, if you do not hit the right average, you actually have to change the number of grading groups. So you have to change your decision in terms of how many buckets and what is the percentages in each bucket in order to hit the right average. So in terms of the distribution model, the only real complicated thing here is that if you choose, let's say, an 8-bracket model, and an 8-bracket model normally gives you a lower average grade than a 5-grading bracket model. You have to choose a grading bracket model that actually hits your targets. So that's one of the things you want to think about up front once you choose how many buckets you need, and then how big a percentage of students do you have in there, because that will determine where your average will be. So that's one thing you have to be a little careful about when you start with the distribution model.
If you're interested in the copy of the spreadsheets I'm using for distribution grading or lift grading, you can just reach out to me with the email you see on the screen.
But there you have it. That's the 2 models. That's the 2 ways to do it. Hopefully this has been helpful. So good luck with your grading, and have fun.